Hey folks, how's it going? So we're going to run through some of the worksheet problems, actually the first warm-up part, and I'm going to jump around a little bit. So I'm actually going to go through all these four, but I'm going to start over here. Once you write Python code, how do you run it? So I'm just going to give you a quick rundown again about like how we write Python code and run it in our computer. And pretty much the quick gist is we use both a text editor like this. So this is something you download from the internet. I'm using this one called Sublime here. And you just make a new file in this like you would anything else. You do file, new file, which I did here, and then I named it warmup.py. So py tells us it's going to be a Python file, and then it's able to color it all nice and recognize it as a file that Python can run. When you make a new file, you just do like you normally do. You just save it in wherever you want to save it. So here I'll do like in my CS10 folder, save it here, and I'll replace the file. It was just the old file of that. So there we go. We have a Python file saved, and then we need to be able to run it, right? So this is just saved somewhere on our computer, and then we use actually our terminal to run it. So our terminal is pretty much our computer, but just running it using text commands. So it shows you what folder you're in right now, what directory we call it. So pretty much I'm in my home directory. It's called Aaron Baker, and I need to go to the directory that holds this file to be able to run it. So in my home directory, I need to go over to desktop first. Now I'm in my desktop, and this is actually in the CS10 folder in my desktop. So I can use this command ls to see which files are in my desktop directory. And we can see that CS10 is one of them, right? So I need to get into that one. So I use the same command, cd cs10. Now I'm in CS10. Let's make sure my file is here. It is. There's warmup. Great. So now that I'm in the folder that my file is in, I can run it using Python. So now, how do you run it? Okay, so there's two ways actually to run it, which is I'm going to jump over to this third question right here. There's a command called Python 3, or you can use Python if you don't have Python version 3. And that's the command you use to run your code, right? So here, let me make sure I have both of these up. I kind of like to have them both up so we can see them at the same time. So you can use this command Python 3, and then that tells us we're going to run some file using Python version 3, or you can run it using an older version of Python like that. But I'm going to go 3. And then you tell them what file you want to run. In our case, it's this file called warmup.py. And hopefully if it runs this right, it'll like define this function, and then we should be able to see this word check printed out because of this function. Boom, done. Look at that. So it went through this file, and it ran it from top to bottom. At the end of it, it printed out this word check. So that's how you run a file. You go to the folder it's in, and then you use this command called Python 3, and it'll run the file that you specify after. Great. So now this third question is asking, there's actually another way to run a file. We just did this one, where you do Python 3 and then whatever file you're running. There's also this other version, or this other command you can use, and it's -i. So it's going to say Python 3 -i, and then whatever file that we want to run. So it's asking what the difference between these two are. And let's take a look at what that is. So while the first one dove in and it ran this file from top to bottom, it bailed back out into the directory that we were in. So it said, okay, I'm done running. Let's go back to our CS10 folder. Great. The difference is, and here, check this out. If I use the up arrow, I get the command that I just did before. So like go to L, So up and down arrow will toggle through those. So I'm going to go up to this one. I'm going to modify it a little bit by putting in -i. Check that out. So what this one's going to do actually is hopefully this -i stands for interactive. So it'll run the file that we specify, warmup.py, from top to bottom, and then when it's done running all the script that we have, it'll keep us in this file so we can start using all the stuff that we wrote, right? So here, let me actually do something real quick. I'm going to create a new variable in here called x. I'm going to set it to like 5, right? Something simple. Now that I edited this file, I want to resave it, right? Because I changed the file a little bit. I want to save it again so that I'm using my must updated file. So there we go. I saved it. You can see the x turned into a little x again. And now let me run this interactive Python 3 -i with the file warmup.py. So it took the file in and it ran it, and it printed checkout, but notice these little 3 arrows. That means we're still in this file. We can access things that we defined in the file. So it ran it from top to bottom, we got check, but now hopefully I should be able to access X. I can. See, we're still in the file, So it gives me this variable x that we defined in it. So that's the difference between Python file name and Python-i file name. The interactive version is really helpful in case you want to like play around with some of the functions you define, make sure they're right. You know, you can do sample inputs, stuff like that. So we're going to stay in it right now. And we're going to actually backtrack up to this question up here and talk about the difference between print and return. Okay. So pretty much the net between these. Here, let's talk about what print does first. We saw a little bit about what it does here when we printed check, right? So you print this word check, and what it does is it shows you what it printed out here on the terminal. So that's pretty much what print does. It takes whatever you put as input, and it'll tell you in like normal human, I can like a description what you inputted into print. So if I print the number 5, it'll show us a nice 5 right here. If I print some function, so here we have a function defined called let's print, or here, let's do a string first. Hi, my name is Aaron. So it'll take whatever's in here, it'll show you what value you did. Boom, print. Hi, my name is Aaron. And it works for any kind of data, and it'll try and describe whatever you put in. So I'm going to put in this function called let's print, because that's kind of weirder, right? Like, who knows how it's going to tell us you put in a function. And it'll do this. It'll tell you, you put in some function here with this weird address and stuff, which you don't need to know about. But it'll say, like, you put in a function. That's a function. That's what print does. It lets you know what you're looking at. Return, on the other hand, it actually gives you the value that you're looking for, right? So if I define some function, func, right, I could define functions in here. You do the same format as in here. It just gets a little tricky. But I can return some value, right? 5, done. So I could do like func plus, and func pretty much for all intents and purposes just returning this 5, right? I can do func plus 4. Oh, I'm sorry, I have to call func. Duh. So that was actually trying to multiply or add a function to an integer, which doesn't work. You can't add a function to an integer. Instead, I called a function, which will return the 5 and add it to the 4. 9, great. So that's what return does. It actually gives you the value in a way that you can use it. Like, I can use that 5. Whereas if I try and like print 5 and then add it to 4, this isn't going to work. So let's take a look at what happened here. You went to print 5, and it'll say, okay, let's show them that 5. Show me up 5. Done. And then use whatever value this returns and try and add it to 4. Well, it turns out print doesn't return the value that it shows you. Instead, it returns this value called a none type. And none type in Python pretty much just looks like this, none. And it's pretty much just this like null value that's like a placeholder of like, this is nothing. This is not a kind of data, right? It's just like, give it a none. And you can't add that to an integer. So that's why you get this error here. So it'd be pretty much the same as doing like none plus 4. It's like, you can't do that. Don't add a none type to an integer. So that's pretty much the basic difference between print and return. Is print shows you the value and then gives you none type as a return value, whereas return actually gives you the value. So I have this function here, let's print, that hopefully shows you a little bit more what it does real quick, because the interactive version of Python has this cool feature. So I'm going to do let's print, and I'm going to put like 10 in there, let's say. So it looks like it does the exact same thing, 10 and 10, right? Because you went in here, and it took the input and it printed it, boom, 10. And then it returned 10. But what the interactive version of Python does, whenever you have these little 3 arrows in here, you're in the interactive version. Whenever you call a function, it'll print out whatever it returns just to show you, just to be like a little helpful. It's like, when I call this function, the user probably wants to see what that function returns. So it also prints it out. So they aren't quite doing the same thing. Print is just showing you the 10 here, whereas return actually gives you the 10. But the interactive Python's like, we probably want to show them it too. That way I can call let's print and like add something to it, right? 10, sorry. And I can add like 20 to it and hopefully get a 30. So it'll print the 10 out, and then it'll take the 10, add it to the 20, and it'll print out 30 to show us what our value is. So that's pretty much the basic difference between print and return. All right, let's jump down real quick and let's talk about the difference between while and until loops. So while loop is pretty much the until loop of Python. The key difference is in here I could say while some condition is true, run this forever. You know, it'll like run the x plus or plus equals. That pretty much says increase x by 1. You know, x is what x was plus 1. So this will run forever because what while does is while this condition is true, it'll keep running this. Once this turns to false, it'll bail and keep going. So I could say like, you know, print, we're done. And so this will actually end up running forever, right? Because this stays true. But I could say while x is less than 10, right? So it starts at 5, while it's less than 10, keep adding 1 to it. And so once it gets to 10, we go here and say we're done, and then we can see what x is. This is kind of the same as until, but instead with until loops, it does kind of the opposite. It says repeat this until this ends up being true. So while this is false, pretty much keep it going. So it'll keep looking for false values, and then once this hits to true, we're done. So if we had some like x, it'll be like repeat until x is bigger than 9, right? I'm not actually going to write the code out, right? But while this is saying while x is less than 10, you would write that kind of in Snap by saying well, until x is bigger than 9, or until it's 10, we could say also, right? Until x is 10, keep adding, 1 to x down here. So that's the difference. Repeat until, it keeps going until it gets some true value, while keeps going until it gets some false value. Just as a quick reminder, let's run this to make sure it's right, make sure it's saved. And once we're in Python interactive mode, by the way, you can get out of it just by writing this exit function, right? So it's exit with this, and boom, it'll get us back out to this directory. So we can run it again, and hopefully what it'll do is it'll print check, set x to 5, and then keep adding 1 to x, and then we're done, and then x is 5. Or 10, sorry. We're done, 10. Great. So that's the difference between those, and that's how you kind of use this environment to be able to write Python code and then run it and be able to check other stuff here, see what x is, blah, 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 error. So hopefully that's helpful, and good luck with the rest of the worksheet and learning more Python.
So how do we translate between Snap and Python? You guys might be like, okay, I don't know any Python. I don't know how to write code. It seems really confusing. But remember that everything you can do in Snap, you can also do in Python. All we have to do is figure out how to translate between the two. So you guys can follow along with your worksheet as I go through these slides. So first we have foo equals 5. So this is a predicate, right? This is where we're checking if the variable foo is equal to 5. We're not setting the variable foo to anything. So in Python, when we want to check for equality, we use the double equal sign. So this would be foo equals 5, and that would check if the variable foo has the value of 5. And this is different, right, from setting the variable foo equal to 5. So this is setting the value of a variable. And with Python, that would be a single equal sign. So this is a really important distinction to make, is the difference between the single equal sign and the double equal sign. Next, let's say we want to change the variable foo by 5. So in Snap, this would increase the value by 5. So it'd be like foo plus 5. And if we want to do this in Python, then we just do foo plus equals 5. And then this is the same as saying foo is equal to foo plus 5. So we're taking foo, adding 5 to that, and then setting that new value to the variable foo. And so these two statements are exactly the same. It's just a shorter way to say it. And this also works for minus, multiply, and divide. Now let's see what happens if we want to set some variable equal to a string. So in Python, a string is like a sentence or a word. It's just a series of letters. So if we want to set a variable in Python to a string, then we'll say the variable name on the left equals, and then the string has to be in quotation marks. So in Python, it can be either single or double quotation marks. It doesn't matter. And we have to make sure we have these quotes around the text. Otherwise, Python will think that it's a variable name if we don't have those quotes. So how do we check the length of a word in Python? It's really easy. We just do len and then parentheses, and then we'll have the string inside of the parentheses. Now, how do I see what a certain letter of a word is equal to? So let's say I want to say, what's the letter 3 of world? Here's where things get a little bit tricky. So we have this bracket notation. So first we have our string, and then we have the bracket after it. And you're like, okay, so I'm trying to find the third letter of the word, right? But then why do I put a 2? And so this is a key difference between Python and Snap. Python is something called zero index, which means that when you start counting up the number of letters, it starts from 0. So the first letter would technically be at index 0. So that's why if we want to get the third item, then we go 0, 1, 2. And then we want to find the second letter, which is actually the third letter in the word. So the syntax would be the string, and then bracket, and then the index inside of the bracket. And then you have to remember 0 indexing. Now let's say we're trying to concatenate 2 words together. So in Snap, this would be joining the 2 words together. In Python, we can just take our 2 strings and then add a plus sign between them, and then this will concatenate them. Now this doesn't automatically add a space between the 2 words. I'm not sure, I don't think Snap adds a space between the 2 words automatically either, so it's the same functionality. You can also add lists in Python together. We'll go more into how to translate lists from Snap to Python later, but for example, if we wanted to concatenate 2 lists together, we can do a list that has 1, and then a list that has 2, and then add those together, and that'll give us a list of 1 and 2. Now, how do I find all but the first letter of word? So this is a key block that we see often when we're doing recursion with words, right, inside of Snap. So if we want to do recursion in Python, then we want to have some similar block. So the syntax we use here is we have the word, and then we have this bracket notation that we saw when we were like looking at the indices of a word. But instead we have this colon in the middle of the bracket. And so this is something that we call slicing. So what a slice is it takes a certain section of a word, right? In this case, we were trying to find all but the first letter of the word. So if you want to slice the word, so we have like everything but the first part of the word, or everything but the first letter, then we do something like this where we have this bracket notation, we have 2 numbers, we have a starting number, and then a colon, and then an ending number. So in this case, we don't put an ending number because if there's no ending number, then Python will assume that you want to go all the way to the very end. Yeah. So the end number is not inclusive. So if you wanted to get items 1 through 3, then you would have to do 1, 4. So it'll go 1, 2, 3, but it won't go up to 4. So the end number is not inclusive. And then, as I mentioned before, if you leave the start blank, then it'll automatically put 0. So if you leave the first number blank and just start off with a colon, then Python will automatically start from the first item. And the same goes for the end. It'll automatically put length of the object there, which will go to the last item. So some more examples are, let's say we want to get letters 2 through 3 of this word. So this will give us RD, right? And again, remember 0 indexing. So if we draw out the indices of this word, then letter W would be the 0th letter of the word. O would be the first letter, R would be the second letter, and then D would be the third letter. So what this slicing does is it goes from the second letter, so we have R here, and then it gets the third letter, we have D, and then we don't get the 4th letter. So this goes from 2 to 3 because this is not inclusive. So now let's look at another example. Let's say we put a -1 as the ending number. So this is something interesting that Python does. Remember, if we leave the start number blank, then it'll automatically go from 0. So we can think of this as going from 0 to -1. But what's -1, you might ask? So -1, this negative number means that it's counting backwards from the end. So it'll cut off the last letter. And then you can do the same with -2, -3, and so on. So if you did -2, then it would count back 2 letters from the end. So what happens if we don't put any start or end number? then it'll go to both of the defaults where the start is 0 and then the end is the length of the object. So that'll just give you the whole word. And just a demonstration of why we use the length of the object. Again, this has to do with zero indexing, and it's sort of one of the reasons why we zero index. So say that word is like 4 letters long, right? So this is technically saying that I'm going from 0 to 4. And then this would get the letters at the indices 0, 1, 2, and 3. So then we have 0, 1, 2, 3. And then that gives us all of the letters. So that's why we use length of the object as the default ending number, because this will just give us all the way up to the end of the word. So another example of slicing. So if we look at this, we're starting from the index 1. So let's label our indices. 1, 2, 3. So this will go from 1 and then go to the end of the word. So this will give us ORD. And then one last quirk about slicing is that we have this thing called a step size. So we can actually add an optional second colon inside of our brackets. And this is what's known as the step size. So say if I wanted to get the word, and I put the default start and the default end, but then I said step size 1. So this is just going to step through each letter of the word one by one. So then this is the same as saying word. But what if I want to step by 2? This is going to give me every other letter in the word. So it's going to start at W, and then it's going to step 2 forward. It's going to W, and then skip over R, and then only go to skip over O, and then only go to R. And then we can also do negative stepping. As we saw earlier with like the negative end, we can also do negative stepping. And what this does is it'll step from the end of the word. So when we were doing positive stepping, then we're stepping from the beginning, right? We're starting at W, skipping over O, and then going to R. So if we do negative stepping, then we're going to start from the end of the word. And then if I do -1 stepping, this is going to start from the end of the word and then go backwards. So this is sort of a shortcut way to reverse a word. So I start at D and then go backwards R-O-W. So I get D-R-O-W. And then again, I can negative step by some other number. So if I did -2, then it would start from D and go every other letter. So go D, skip over R, and then O, and then skip over W. So we get D-O. All right, now let's talk about lists inside of Python. So we have this list 1, 2, 3 in Snap. And if I wanted to make this a list in Python, then I just start off with brackets, and then I put each item in separated by a comma. So I have 1, 2, 3, and then brackets on both ends. Remember that these are square brackets, these are not parentheses. So those are 2 different things in Python. So what if I want to get the first item of the list? It's the same syntax as when we're getting items from a string. So we have 1, 2, 3, and then we put this bracket after it with the index that we're trying to get. And then again, remember list indices also start from 0. So lists and strings in Python are both 0 indexed. Now let's say I wanted to get the last item of this list. We could either go backwards and grab the -1th item, which would be the last item, or we could do list of length of list -1. And this -1 here comes again because of our 0 indexing. So just as a small toy example, the length of this list is 3, right? List is equal to 3. And then these would be the indices. So I have 0, 1, and 2. So if I wanted to get the last item of the list, then I would have to try and get this second item, right? So that's where I have length of list, and then -1 will give us the position of the last item. Now, how do I find the length of a list? Again, this is the same syntax as finding the length of a string. And so you'll notice that there are a lot of similarities in how we deal with strings and lists inside of Python. So I'll just do length and then put the list inside of the parentheses. So if you wanted a quick refresher on how to do it for strings, it would be like something like this. So same thing, except we just put a list inside of the parentheses instead of a string. All right, now how do we add items to a list? So in Python, in Snap, this is adding 4 to the end of the list so that we get a list 1, 2, 3, 4. And then in Python, we have to do this weird .append syntax. So to break this down, first, I have the list that I'm going to be appending to. So I have this list 1, 2, 3, and then I'm going to append 4 to this list. Now, there's one key thing to remember. Append mutates the original list. It does not return a new list. So if I said like some variable new list equals this statement, this is going to return an error because append doesn't return anything. So if we wanted to get a new list, we'd have to use this syntax here, where we have a list 1, 2, 3, and then plus a list that contains 4 in it. And then this would give us, this would return a new list of 1, 2, 3, and 4. So let's look at another example of what exactly this append is doing. So let's say I had some list. So list equals 1, 2, 3. And then I wanted to append onto this list, right? Then I'd have to do list append of 4. And now what this does is this mutates this list variable here. So I don't set this append statement equal to anything. I don't do like list equals this because append doesn't return anything. It doesn't report anything. Instead, I just have the statement list.append 4, and this will mutate the list variable. So it'll mutate the variable and add 4 to the end. Now, how do I delete the last item of a list? So in order to delete the last item of a list, Snap has, or Python has this special function called pop. So I'll just do list.pop, and then this will pop off the last item of the list. So pop, unlike append, it returns the item that it popped off. So if I were to say a equals this list 1, 2, 3 dot pop, then a would be equal to 3 because pop returns the item it popped off. You can also pass in an index to pop. For example, if I wanted to pop off the first item instead, if I wanted to delete the first item of a list, then I could do this list.pop of 0, and then this would return 1, and then it would also mutate this original list so that it's only 2, 3. So pop is also a function that mutates the list. It doesn't create a new list. So if I were to say list equals 1, 2, 3, and then let's say I wanted to pop off the second item. So the second item would be putting in this index 1 here because of 0 indexing. So this is 2. 2 is at the index 1. So it would delete this 2 and mutate this list. Now, how do I delete the first item? You kind of saw it earlier, right? We can pop off the first item. Yeah, so we just put in this the index 0 into pop. And again, this mutates the list. It doesn't create a new list. It returns the item it popped off. So this would return a 1.
So now let's take a look at how to convert functions and loops from Snap to Python. So here we have this for each loop in Snap where we say for each item of this list, 1, 2, 3, say the item. So this syntax looks pretty similar in Python. We start off with this for keyword, and then we say some variable name. So in this case, our variable name was item. And then we say for item in our list, and then we put a colon at the end. And then after that, we need to make sure whatever we put inside the for loop is indented. So notice how the print statement is indented like 1 tab amount to the right. So we want to make sure it's indented so Python knows that statement is part of the for loop. One thing to note is that this variable name can be whatever we pick. So in Snap, the default variable name was item, right? But if we go to Python, we can change this variable name to whatever we want. If I were to say like for potato in list 1, 2, 3, print potato, then it would be the exact same functionality. And then don't forget the colon, or else Python will throw a syntax error. So now let's look at how to convert the repeat until block in Snap to Python. So in our example here, we say repeat until foo is empty, foo is a list, and then we're going to delete the last item of foo. And we're going to keep deleting the last item of foo until foo is empty. So there's not a direct translation from this snap block to Python. What we have in Python instead is something called a while loop. And the while loop, it's sort of the opposite of what a repeat until block does. So let's look closely at this repeat until. So with this block, I'm repeating the inside until this predicate is true. So I'm saying I'm going to keep repeating this delete statement until this predicate becomes true. But now with our while loop, we're sort of doing something that's the opposite. So in this case, I'm saying while the length of foo is greater than 0, then pop off the last item from foo. So I'm going to repeat whatever's inside this while loop until this condition is false. So you can think of this as being like repeat until length of foo is equal to 0. But with the while loop, we're saying while length of foo is greater than 0. So we're sort of like using the opposite condition. Now let's look at how we define functions inside of Python. So say I have this function called count to n, and then n is a variable. And then inside of my function, I'm going to say for I from 1 to n, say I. So this block actually has two things going on, right? First, we're defining a function, and then we're also doing a for I loop. So starting off with defining the function, we start off with this def keyword, and then we have the name of the function afterwards. So in this case, I have count2, and then I have this parentheses, and then the name of my inputs inside of the parentheses, and then I have a colon at the end. One thing to remember is that your inputs can be any variable name that you choose, and then your function name has to be continuous. So I can't have any spaces inside of my function name. I have to connect it with this underscore, or else Python is not going to recognize it as a function name. And then again, like the for loop that we saw before, with a function definition, I have to make sure whatever comes after the colon is indented so that Python knows whatever's indented is part of the function. And then converting a for I loop from Snap to Python, it's pretty similar to the for each loop. We have this for keyword, and then we have our variable name. So in this case, I picked I, but again, this variable name is arbitrary. So I could say like for potato or like for cat, and it would be the same thing. So I'm going to say like for I in range 1 to n plus 1. And if you guys haven't seen this range function before, basically what it does is it goes from this first number here and then counts up until the last number minus 1. So if you remember slicing, you know how the last number in a slice is not inclusive? It's the same for range. So if I were to say, if I wanted to get like range from 1 to 10, then this would output 1, 2, 3, all the way up to 9. So it's not inclusive of 10. And that's how you write for loops and function definitions in Python.
Hello, Mertz here. So I will be going over the translating functions section of your discussion worksheet. So you should be able to see it on the screen here. Let's start with the first one. We want to translate is word long into Python code. And so the first thing we want to do here is define a function. And the way we define a function in Python is we use the def keyword, and then we give it whatever name we want. In this case, I'll just call it word is word long. And remember that we pass in all of our, let's make this a little bigger. We pass in all of our parameters or our inputs at the end in Python. So we can put our input word here. Then we want to check if the length of our word is greater than 5. So we use the len function in Python. So if len word is greater than 5, then you put a colon. This is the syntax you learned in the lab. we return true. Remember, we don't report in Python. Otherwise, so we type in our else keyword, we will return false. And well, that's pretty much it for the first one. Some key things to note are that, like I mentioned earlier, the input is always at the end here. The length of word function is then translated to be a len function in Python, and we use the return keyword, not report. And in the next video, I'll go over part B. Okay, so now let's do the second one, which is a little bit more difficult, but still the same basic idea. So we'll define our function, which will be called distinct, and it will take in one argument, one input, LST, representing a list. Now, we're going to write a nested for loop, but we want to notice that the numbers are slightly different because Python is 0 indexed. So let's really quickly note what the first one is saying here. We want to go from the first element of our list for I equals 1 to length of list minus 1. Now, what does that mean? That means that we want to include everything except the last element. So in Python, we use the range function, right? So we'll write for I in range, and we want to start with the first element, which in this case would be the 0th element. So we don't need to give range its first argument. I'm going to do it anyways to be explicit since we're just starting out. So I'll write for I in range 0 to what? Well, since Python is 0 indexed, right? The last element of your list, if your list, for example, has 6 elements, then the last element is going to have a length the last element is going to have an index equal to 5 because you'll have 0, 1, 2, 3, 4, 5 for a total of 6 elements. So we don't want to include the last element. However, it's also important that Python doesn't include the right number when you're using range. It's not inclusive of the right side. So for example, if I did for I in range 0 to 3, it would only go from 0, 1, and 2. It wouldn't include 3. So all that we really need to make sure is that we get all of the elements up to the last one. So we can actually just write length of list minus 1. And what's the reason for that? Well, the reason is that if we do length of list minus 1, let's just use an example. Say that we had 5 elements in our list. That means we want to consider elements 0, 1, 2, and 3, because the last element will have index 4. So if we use this example here, the length of the list is going to return 5, and 5 minus 1 is 4. But we won't include 4 in this range. So we'll get 0, 1, 2, and 3, which is exactly what we want. This is just a continuation of the last video. I recommend watching that last one one more time if what I said confused you, because it is a bit weird to grasp at first, which is why I gave it its own video. But the rest of this is pretty straightforward. So now we can just say for j in range, I plus 1 to length of list, right? Because j is going to want to include everything, including the last element. In Python, length of list is, for example, in a 6-item list, going to return 6. And even though 6 isn't included, like we mentioned before, since the last element is going to have index 5, this will work. And then we just check if list I, this is how we get the ith element of a list using this bracket notation, equals list j, we return false. Now, otherwise, if this doesn't happen for any of the cases, we return true. And you want to make sure that our indentation is correct so that this return statement is outside of both of the for loops. And, well, that completes it. So that is translating functions from Snap into Python.
Hey y'all, welcome to Python, and I guess let's do some Python coding questions. So this problem is just trying to find the number of times a given letter appears in a string. And we want to do this both iteratively and recursively. I personally think iteratively is like conceptually the easier one to start off with, so let's do that one first. So basically what we're wanting to do is we want to check a letter. So we can look at these example cases that I wrote out. We want to check, in this case, how many times S appears in CS10. It only appears once, so we'd want to return 1. And the basic idea behind this would be, let's see if S is the first letter. It's not, so then let's see if S is the second letter. It is. So now we know S is in it once. Let's see if it's the third one. It's not. Let's see if it's this, it's that. So we go through the entire thing checking to see how many times S appears in it. And we would do the same here with X because the string is empty. There wouldn't be in it any times. We'll check with E. Berkeley has 3 E's in it, and so that would return 3. So let's think about how are we going to be able to do this? Well, the first thing we need to consider is how we're going to keep track of how many times our letter appears. And for that, we can create some kind of counter variable. I'm just going to call mine counter. And then we want to go through every single letter in string. And a good way to do that is using for loop. So we can do for each letter in string. And now what we want to do is we want to check if letter equals the letter we're looking for. If it does, we want to increment our counter by 1. If it doesn't, we don't want to do anything. So we actually don't need an else case in this instance. And this for loop will go through every single letter in the string. And so once we leave the for loop, we just want to return whatever counter is. And let's check to make sure that works. And it does. S is in CS10 1 time, X is in an empty string 0 times, and E is in Berkeley 3 different times. So that's how we do it iteratively. So now let's do this problem recursively. And the way we approach any recursive problem is we have a base case and a recursive case. So the base case is the simplest that this problem can be. And I personally start with the base case just because I think that's an easier way for me to approach it. But you can always also start with the recursive case. So let's think about the base case. What is the simplest this could be? Well, if we had an empty string, then we know that we have to return 0 because a letter can never be found any number of times if nothing's in the string. So the way we can check that is we can check to see if the length of the string is 0. And if it is, all we want to do is return 0 because there's nothing in the string, that letter is not going to be in it any number of times. So now we want to think about a recursive case. So recursive case, the first thing we want to do is we want to check to see if the first letter of the string matches our current letter. So the way we can do that is we can actually index into string. This is basically the same thing as getting letter 1 of string. But so if the first letter equals the letter we're looking for, then we'd want to return 1, right? But we also need to go through the rest of the list. And so that's where we have to basically recurse through this. So we'd want to call find num of letters. We still want to keep the same letter, but we want to do everything but the first letter of the string. So this is basically all but first. And we can do that with slicing. So this will start at this first element because Python is 0 indexed. So it'll start at the first element and go all the way through string. And so this is where we get our dividing part of recursion. This is the invoke, and this is the combine. So we're only missing one tiny thing. Say the first letter doesn't match the letter we're looking for. In that case, we still need to go through everything else. So we can actually just write an else statement, and we just want to return a recursive case. And we just want to return a recursive case. Because the string, the letter doesn't match the letter we're looking for, we actually don't need to add 1 because it's not the right letter. So in this case, we're checking to see if S equals C. It does, S doesn't equal C, so then it would just go check to see if S equals the rest of this part of CS10. And let's test it to see if this works. I should probably save it. And it does. So that is the way we would solve this problem recursively.
To start this function, we'll make the range of the numbers that we're iterating through. So to write that in Python, we would do for I in range 1 to 101. And the reason that it's 101 and not 100 is because in Python, ranges work where you go from the first number up to and not including the last number. So now we have our like conditional statements, and they're pretty similar to like how you would write snap statements. So if a number is divisible by 15, and I'm doing 15 first because if a number is divisible by 15, it's implied that the number is also divisible by like 5 and 3, but we just wanted to print Fizzbuzz and not Fizz and Buzz. So there's an operator in Python called modulo, which returns like the remainder of two numbers. So if the remainder of I and 15 is 0, then that means that I is divisible by 15. So let's print Fizzbuzz and then move on to the next case, which is, well, we could do if I mod 5 is 0 or I mod 3 is 0, it really doesn't matter. Well, actually, this should be elif, because that's basically saying if the thing before it wasn't true, like if this didn't evaluate to true, then we check this next statement. And so those are our three like main cases, but the other thing is that if a number doesn't adhere to any of these, then we just print that number. So else print I. And let's test it in my terminal. Yeah.
Okay, so we're going to go over this problem errors galore, which is basically just going through this code and fixing the syntax errors in Python. So the function is floor divide, basically dividing the bigger number by the small number, but rounding down to the nearest whole number. So we start with def floor divide big num small num colon if small num equals 0. Remember in Python, an equal sign is an assignment statement, whereas equals equals is actually is this the same value as this? So this here should be an equals equals. And then when we're returning something inside an if statement, it should be indented. And then since we're returning you cannot divide by 0, that should be a string. So this needs to be in quotes. It could be in double or single quotes. Doesn't really matter. Then we have current num set equal to small num, and then num times equals 0. But since num times is one variable, we need to connect it with an underscore. And then we have while current num less than or equal to big num, and there should be a colon at the ends of loops or if statements. So we have a colon there. And then current num plus equals small num, and then num times plus equals 1. Again, since num times is one variable, it should be connected. So we can do that with an underscore. And at the end, we report num times. In Snap, we use report at the end of each block, but in Python, we will use return. So now if we run through this code, def floor divide the big number by the small number. If the small number is 0, return you cannot divide by 0. Otherwise, set the current number to the small number and set the number of times equal to 0. And while the current number is less than or equal to the big number, add the small number to the current number and add 1 to num times. And then each time you go through this while loop, current number will increase by small number. So num times is counting how many times small number evenly goes into big number without exceeding it. Oh, I forgot those two. There should be an underscore under num times. Hope that makes sense.